So when 1 unit of electric charge from one point to another point, the amount of work done in moving that is in joules is known as potential. Electric potential. If electric potential is not being given from one point to another, it is being given not the infinity, so it is potential difference. And if it is being given from infinity to a point, then it will be electric potential only. Next question is the hindrance presented by the materials of conductor to the smooth passing of electric current is known as resistance. Okay. Next one is question number 3. If you are talking about question number 3, so in question number 3 we have 40-volt battery is connected across an unknown resistor. There is a current of 100 milliampere in the circuit. So we have the potential difference of 40 volt. So what is the answer for this question?
Sir, I got the answer as 400.
400. None
Oh,
of these.
yes.
According to you, none of these, na?
Yes, sir.
So potential difference is 40 volt. V is 40 and is connected across an unknown resistor, and there is a current of 100 milliampere. So I is 100 milliampere can be written as 10 to the power minus 3, or it can be written as 0.1 ampere. Okay, find the value of the resistors with R. So R is equals to V by I. So V is actually 440 upon 0.1. So you will get 400. So this is none of these. Next question
Sir,
is,
in question number 2, uh,
yes,
it should be resistivity, right? Since it's talking about only the material of the conductor.
hindrance presented by a material of a conductor. By a material. So resistance also produced, means it is also property of a conductor we are talking. Hindrance presented by a material of conductor to the smooth passing of current is known as. So it is not saying that means resistivity is also a resistance of per unit length. The resistance of a biconductor having a cross section area of 1 meter square and per unit length of length 1 meter. So it is resistivity is also a type of resistance. Okay, they are not different units. Okay, that's
Okay,
why it
sir.
is ohm meter. So if it is option is given resistance, so don't go through the resistivity. Okay,
Okay, sir.
next one is, we can say the electric fuse is based on
Heating effect.
heating effect of current. Is based on heating effect of current. Uh, which of the following has no plus and no minus sign marked? Okay, no plus and no minus. So we'll say that no plus and no minus, which is that one?
Resistor.
Yes, a resistor is the one which is not going to have any plus and any minus sign marked. Okay. The next one is two bulb 100 watt 20 rated with this, connected with this one, another one with this one. Which one has the greater resistance?
Sir, the second one with 60 watt and 220 volt.
Has a greater resistance. Yes, if
Yes.
it is, if they are alone, they are single, then the less means more power bulb is going to have the less resistance. Okay, and the when they are connected in series, for example, if they are connected in series, then the bulb which is of high power will have low resistance. Okay, so here if they are connected in, like for example, if they are alone connected means they are connected single with 220 volt. Okay, so this is connected, this is 100 watt bulb, this is 60 watt bulb. So if they are alone connected, then we consider them as they are connected in parallel. Okay, got it? So
Yes,
this
sir.
this is 60 watt. Now P is equals to, I is not mentioned here only. So P is equals to V square by R. V is directly proportional here. So we can say that P is inversely proportional to R. So in parallel, so because V is same in both 220, 220, so we'll say that more the power, less will be the resistance. Okay. So it is asking which is going to have the greater resistance. So greater the resistance, less will be the power. So this one is the correct. Okay. Next one is how much energy is given to each coulomb of charge passing through a 9-volt battery. Energy is being asked. What's the formula for energy? How much energy is given to each Coulomb charge? Each Coulomb means Q is 1 Coulomb. Okay. So energy is being asked. So what's your answer? Q is 1 Coulomb.
Sir, I got 9 joules.
V is
9.
9 volt. Okay. So you know that energy and the unit of energy is joules and work done is also joules. Okay. So which formula will you use here? Don't use H is equals to I square RT. We don't have this R resistance and time. We know that energy is being asked, but actually it is being asked energy and work done has the same unit. Work done has the same unit. Okay. So we know that V is equals to W upon Q. So W is equals to V into Q. Okay. So multiply V into Q. V is 9 and 1 is Q. So when you multiply 9 into 1, you will get 9 joules. Okay. Got it?
Yes, sir.
Question number 9. A wire of resistance 10 ohm is bent to form a circle. What is the effective resistance between the 2 points at the end of the diameter of the circle? Tell me. Tell me.
Sir, I considered it as two parallel resistors, since if it's in a circle, then the two ends of the diameter are parallel to each other. So I got 5 ohm when I calculated.
You get 5 ohm. Okay. So when it is saying that if you are going to have a wire, so let's consider that wire is going to have 10 ohm. So total wire of 10 ohm is bent. So when a wire of 10 ohm is bent, so when you bend it, it is like this. Half of the wire will be like this and half of the wire will be like this. Okay. And this half of the wire is going to have 5 ohm resistance. This is also going to have 5 ohm resistance. And they are connected now to this diametrical end. Means actually we can simply say that this is the 5 ohm resistor like this. And this is the another 5 ohm resistors like this. Because half wire is going to have, if the full wire is 10 ohm, then the half wire will be going to have how much? 5 ohm. Okay. Got it? So here, if you take out the equivalent resistance will be R equivalent in parallel is equals to R each if they are the same divided by N. So if the two resistors of 5 ohms are connected in parallel, so you'll write it 5 divided by 2, you will get 2.5. 2.5 ohm.
Sir,
Understood?
but
Yes.
what if the wire only one wire is used and a circle is made from the bending the wire? So
Yeah. Yeah. This is the same question that for example, if you are having a wire, if it is of 10 ohm, okay, 10 ohm. So if you bend it, so it is a single wire like this, but don't consider it as single because now here when you end it like this way, so this wire is this only this wire is going to have 5 ohm because this length is of 5 ohm. Okay, this is the half. Okay, half length, and this is also half length. Okay, got it?
yes, sir,
This
got
is
it
5
now.
ohm, this is also 5 ohm. The whole wire is going to have 10 when it is connected. When you are connecting it with the diametrical end, so you will get 1 by 5 plus 1 by 5. You will take 5, 1 by R equivalent. So you will get 2 by 5. So when you reciprocal this one, 5 by 2, so you will get 2.5. Okay, understood?
Yes, sir, understood.
Next one is how does the resistance of the wire, how does the resistance of the wire changes when the length is tripled? When the
Uh,
length, yes.
Resistance is directly proportional to length, so when length increases, resistance will increase, so resistance is tripled.
Okay, if the radius is tripled,
uh, area will be 9 times and resistance is inversely proportional, so resistance will decrease by 9 times.
So it will become 1/9 of the
Yes.
original. Yes. Okay. Not don't write decrease by 9 times. Write the words. It become 1/9 of the original. Okay. Because decrease by 9 times is making this means, for example, okay, for example, if I'm saying that it is first 90 ohm, now when you triple the resistance, then it will become 1/10. Sorry, 10 ohm only. Okay, 10 ohm. So now it is decreased by 8 times. Okay, because it is on 9 already 90 to 10. So if you use this word to write, use the word, it will become 1/9. Okay, of the original. Ammar, are you getting? Ammar, are you there?
So like, yes sir, now.
Are you getting?
Yes sir. But
Let me help you that how it will become 1/9. For example, if I'm saying that resistance formula is rho L by A, okay, and rho is resistivity and length is the area length of the wire and A is the area of cross section. So area of the cross section is like this circular end of the wire we have circle. So this is pi r square. Okay. So if I'm saying that the original resistance of the wire is rho L by pi r square. So the new resistance will be rho L and the radius has been changed to radius is tripled. So we'll write pi 3r square here because the radius has become 3 times. Now r dash is equals to rho L pi 3 is the 9 r square. Now bring this 9 to this side. You will say r dash is equals to rho L by 9 pi r square. This 9 we cut it to this side. Okay. Now if you see this one, you can write it r dash is equals to 1 by 9 into rho L pi by pi r square. And what is this? This is the original resistance. So r dash is equals to 1 by 9 to the original r. Okay. Understood? Copy this one. Copy this one, please. Done? Done you both?
Done, sir.
Okay, done. Now, if its material is changed, what should be the answer? Its material is changed to one whose resistivity is 3 times. Tell me, Abir.
So resistance will
Will what?
become 1/3.
Why? It is directly proportional. You have the formula R is equals to rho
Rho
L by
L.
A. So you write 1/3. R is equals to rho L by A. And what is rho? Now, this is the original resistance. Now the new resistance is, the resistivity is 3 times. So rho L, 3 times, it has become 3 times of the original. And LA and R fixed. So you can write 3 bracket rho L by A, and this is original R. So you can write 3 R. This is very simple.
Noted, sir.
Okay, next. So next question is, list 2 reason why nichrome wire is used for heating element. Have you mentioned?
Nichrome is an alloy of nickel and chromium, and alloys have greater resistivity but do not burn easily under high temperature, so it is used for making heating elements of electric appliances.
Yeah, you can say. Distinguish between resistance and resistivity, have you mentioned?
Yes, sir, I wrote that. Resistance is the ability of conductor to oppose the flow of electrons, and resistivity is the ability of material. Resistance depends upon length and area, whereas resistivity is independent on those factors. And the SI unit of resistance is ohm. Resistivity is ohm meter. And I wrote the different formulas of
So
resistance and
have you noted that the resistivity is the resistance per unit length, resistance offered by a conductor per unit length and per unit cross section area?
no, sir, I just wrote it is dependent upon length and area of conductor.
Okay. Okay. The resistors are generally thin. Just compare aluminum wider X expression for parallel and series combinations. So this up to here we have studied in our classes. So let's move and finish this chapter today. Okay. So today we're going to study power. Power. Okay. What is power?
Uh, Power
Power
is
is
the
rate.
energy consumed in certain time.
Yeah. Power is rate of doing work, you know. Rate of doing work. Power is actually rate. Yeah, you can say rate of rate of doing work. Doing work is called power. Is called power. Okay. What is rate? Rate means whenever we are saying rate of doing this, so rate of something, rate of flow of charge. So rate means divided by time. Okay.
Divided by time.
And this is time, and this is work, and this is power. Okay. And the SI unit of power is watt. Watt. Or you can say work done unit is joule. Joule. And time is second. So you can write it joules per second. Okay. Got it? Got it?
Yes, sir.
And if I multiply this one, work done. So you can say that work done is also equals to power into time. Power into time. And we have several formulas for power and time. Okay. So like we have power formula is P is equals to VI. Power's formula is also is V square by R. How? Because you know that if we don't have I and we have resistance, so we have the formula I is equals to V by R. Okay, so if I write in place of I in this formula as V by R, so V is already written. In place of this I put this value V by R. So this will become V square by R. Amar, are you getting? You are not responding anything. Amar,
Sir?
are you getting?
Yes.
P is V square by R. Okay. P is V square by R. Now we are just moving. Next one is P is equals to, we can have the next formula. If we have only, if we need to keep I and we need to replace V by I in terms of I and R. So you can write V is equals to IR. So if we have V into I, so we can write it in place of V, we can write I into R, this into I. So P is equals to I square R. Okay. Understood?
Yes, sir.
Okay. Now, these are the three formulas. First is this one. The second is this one. And the third one is this one. Okay. Similarly, if I multiply it by time, so power into time is equals to work done. And work done is also going to have the same power into time is equals to work done. And work done and energy has the same unit. So if I multiply power by time, here by T and here also by T, so it will become work done. So we can write, and work done is also equals to energy. So work done is also equals to energy. And we can say that power into time is equals to energy. So we can have the formula of power. What we're having the formula of power? We're having power is equals to VI. We also having power is equals to I square R. And we also having power is equals to V square by R. So this is power. But if I multiply it by time, all by time, so it will become energy, because power into time, energy. So energy generally in this we have in the form of heat. So heat energy heat produced is equals to this one. Okay, you understood?
Yes, sir.
Yes.
Okay, now we also have a formula of energy. Energy is that we were studying, that V is equals to W by Q. So this, if we multiply to this one, so this is also equals to W is equals to VQ. And W, you know, work done, so you can write the energy. Energy is also equals to V into Q. Okay, this is also another formula. Any heat energy is also equals to V into Q. You can, these are the four formula of energies. Okay, but where you are going to use these formulas, let me explain you. If you have the formula P is equals to VI, if you have the formula P is equals to I square R, if you have the formula P is equals to V square by R, so here this formula will be used where V and I both are given in the, okay, and this here we can say that, okay, this will be used where I and R is given in the question and P is being asked, and here where V and R is given to you, but I is not given, or it is been given but you are not using this one. Done? Is I audible?
Done, sir. Yes, sir, you're audible.
Okay. So now moving to the next part is, my voice is breaking now. Hello. Is I audible? Hello.
Yes, sir.
Okay. So if I'm talking about this one is P is equals to VI, P is equals to I square R, P is equals to V square by R. Okay. Now moving to the next one is if I'm talking about this one, where are you going to use? So first of all, let you know how to calculate the resistance of the conductor. And if I'm talking about this one, for example, if you have a potential, if you need to calculate, if you have some resistors connected in series, then in series, we are always going to have the same current. And the total current you need to calculate. You need to calculate the total current of the circuit. Okay, you are not going to calculate the current of the first resistor or second resistor. For example, this is 5 ohm resistor, this is 10 ohm resistor, and this is this is 20 or 15 ohm resistor, let's suppose. And this is a 30-volt battery, it is being connected. So if I ask you that what is the resistance of this conductor? Sorry, what is the current through this conductor? So don't calculate the current only uh, in this one of this one, or don't write it like this. I is equals to V by R. So don't write it V is 30 here, and R is, don't write it 30 divided by R, or don't write it 30 divided by 15 like 2 ampere. No, it will be incorrect, because in series the potential difference divides. So if you think that the 30 volt will reaches to this one, it is incorrect. The 30 volt will not reach to this one. Got it? 30 volt is not going to reach in this resistor. Got it?
Yes, sir.
So how will you calculate the resistance of this one? So this is very simple. First, you need the equivalent resistance of this one. So what is the equivalent resistance? So you know the equivalent resistance of this conductor is 5 plus 10 plus 15. Because they are connected in series, you add them directly, you will get 30 ohm.
30.
So now you have to write it. I is equals to V by R. V is 30 and R is 30. So you will get 1 ampere. So 1 ampere is the total current of the circuit, and the total 1 current will be reached to every part. Okay. 1 ampere to this one, 1 ampere to this one, 1 ampere to this one. All of them are going to have the same. Okay. Got it? Got it?
Yes,
Same
sir.
current. Now, if I ask you that calculate the power of this one, so now you have calculated, now you have three formulas. P is equals to VI, P is equals to I square R, and you have P is equals to V square by R. So you will not use this formula and this formula, because the potential difference is not same. Okay. Because potential difference 30 is not reaching here. So which formula you will use? You will use the I square R. Now you can use the V also, but you need to calculate the V along this one, that how much voltage is reaching to this one. Then you can use this formula if you are able to calculate the voltage that are reaching to this resistors. And this is another task. Okay. So you have calculated the current, that 1 ampere current is reaching to this resistor. So reaching current and reaching resistance is there. So you can use this formula. So P is equals to I square R. So you can write I is equals to 1 ampere, 1 into 1 into resistance is 15. So we'll say 15 watt will be the power of this resistor that it is consuming. Okay. Got it? Got it?
Yes, sir.
And similarly, if I connect all these three resistors in this, suppose if I'm connecting all these resistors like this in parallel to each other with a volt of 30 volt battery. Okay, this is 15 ohm, this is 10 ohm, and this is 5 ohm. And if I ask you to calculate the resistors, okay, calculate the resistance. So what you will do here?
1 by R plus 1 by 5 plus 1 by 10 plus 1 by 15.
Yes, you will do. No need to calculate, because 30 volt is being reached. If I ask you that calculate the resistance, sorry, calculate the power by this one. So we have three formula.
So
P is equals to VI,
V by R.
P is equals to V square by R, and P is equals to I square R. So in in parallel, current difference, current changes. Not the current is going to be, the equal current will not reach to this one, to this one, to this one. So the I containing will not be here. They will not be used. Only this formula will be used.
V square by
V
R.
V square by R. Now you know that in parallel the potential difference remains same. So every resistor is going to get the same potential difference, 30 to this one, 30 to this one. So you can write 30 into 30 divided by 30. Sorry, divided by 15. V is 30 into 30 divided by 15. You will get 2. You will get 60 watt. not at power. The power consumed is 60 watt. Understood?
Yes, sir.
So this is the way how we calculate. So let's you do a question here. Here we have this question.
Sir, 60 watt will be the power of only the 15 ohm resistor.
Yeah. Only the 15 ohm resistors only. Okay, do question number 14. Do question number 14. Are you doing?
Yes, sir. Sir, for the first one, I got 12 watt as the answer.
It is incorrect. Check where you have committed the mistake. Done?
No, sir. One second.
You have to compare the resistance. 2 ohm resistors used in parallel with 1 and 2 ohm resistors connected in series with 6-volt battery. Okay, 1 and 2 ohm. 2 ohm resistors connected in series with 6-volt battery. And we have 2 ohm and 12 ohm resistors connected with 4-volt battery. 2 ohm and 12 ohm resistors connected in with 4-volt battery. You have to calculate the power in each case of 2 ohm resistors only. This one only and this one only.
The 2 ohm resistors connected in parallel has less power than the 2 ohm resistor which is connected in series.
Okay, so what is that value? What is that value? Okay,
For 2 ohm resistor in parallel, I got 8 watt.
8 watt. And here, in the first
Sir, I
one.
checked, but I'm still getting 12 watt.
Okay, so what is the total current in the circuit? What is the current of this one? How you used, which formula you used in this one? P is equals to which formula you use in this one? Tell me.
Sir, I used I square into R.
I square into R. And what do you use the value of I?
I got 2.
You got 2.
Yes, so
2
2 square
into 2
4.
into 2, 8.
No, sir, 2 into 2 and resistance 3.
Why 3? It is asking only about this 2 ohm resistor. It is not
Okay, sir.
asking about the whole.
Yes, sir.
Okay. And how you get I, the total current? Because in series, the total current is considered to be as the current of individual resistors also. Okay. So in series, whenever you are just calculating, that's why we just calculate the total current, because the total current of the circuit is considered to be as the, okay, got it, as a circuit current. Don't consider this as, okay. So it will be considered, means you will take total R equivalent is equals to 1 plus 2 is equals to 3 ohm. Okay, and we will have V is equals to, sorry, I is equals to V by R. V by R, so total V is 6 and total R is 3. So you cut it, you will get 2 ampere. The current is 2 ampere. The 2 ampere current is flowing in this one also and in this one also. So both are going to have 2 ampere current. So for example, if we are just going to calculate the rest power of this resistor only, then we will not use this one. We'll use this one only. So P is equals to I square R. The total I is 2 into 2. Total I is 2 and R is also 2. So that is 8 watt. Okay. And here is also, here this resistor is going to get the voltage 4 volt, because if they are connected in parallel, so in parallel voltage remains same. So this resistor will also get the 4 volt. This resistor will also get the 4 volt. So we will use voltage and resistance formula. P is equals to V square by R. Then P is equals to, what is V? V is 4 into
4.
4 divided by 2. You cut it, you will get 2. So 4 into 2, you will get 8. Okay. 8 watt.
Yes,
You
sir.
understood? Okay. The next formula, next question. Okay. Okay. Do question number 12. Do question number 12. Done? Done?
Sir, I'm not able to get the answer.
This is okay. Let me help you. There are several electric bulbs that are connected with 220 volt battery. Okay. Let me help you. Okay. Okay. It's simple. Okay. There are several electric bulbs that are connected. Okay. With 220 volt battery. 220 volt battery. Okay. And across a line, and the bulb is, each bulb is 10 watt rated. Okay. So when we are just connecting each and every bulb in parallel, their power keep on increasing. Okay. Their power keep on increasing. So for example, total power is equals to total power. P total will be equals to, if suppose power of one bulb plus power of second bulb plus power of third bulb, okay, and so on. So we can say that if n numbers of bulbs are connected of same rating, so we will have total P total is equals to n number of bulbs into power of each bulb. Power of each bulb. Okay. Understood? Got
Yes,
it?
sir.
Now, how many bulbs can be connected? Now you need to calculate the value of n of across. If the maximum allowance current is 5 ampere only, means if the main line with which the powers are being connected, it can allow the 5 ampere current. So you know that P is equals to V into I. So right here, total power is equals to V into I is equals to N into power of each bulb. The power of each bulb is 10. Got it? Or you can write it power of each bulb. Power of each bulb. Okay. Now you can write it like this: 220 into maximum allowance current for is 5 ampere only. N is the, you need to find out, N is 10. So this 10 will comes down. This will get 220 into
So
5.
110, sir.
Yes, you can cut it. You will get 110 bulbs. N is equals to 110. You understood, Amar? Amar,
Yes, sir.
you understood?
So can I write it? Yeah, can I write it down?
What are you saying? Can I?
Can I write it down?
You didn't understood.
So can I write it down? Sir?
Yes.
Okay.
Yes. Are you
Yeah,
saying
can I
something?
write it down?
Yes, yes, Amar. Write it down. Done, Amar. Should I move forward? The last question. The last question. Two lamps, one rated with 100 watt, 220, and another is 60 with 20 watt, are connected in parallel. What's current is drawn from? So you need to find out the current. So can you be easily find out the current in each case? Tell me. Tell me. Abir, are you there? You are muted.
Yes, sir.
Will you be able to find out the current in this case? Two lamps, one rated with 100 watt, other with 20, means they are both connected with, one is 100, another one is 60. They are connected. So will you be able to find out? This is very simple. P is equals to VI. P is given to you, V is given to you. You can find out the current. Okay. And if they are connected in parallel means they are individually connected. Okay. So if it is asking about what is the main current they are withdrawing, okay, so you can add up the power and then you can use this. Okay, because if we are connecting something in parallel, so it means they are individually connected like this. Okay, like this. Calculate the power of this one, power 1. Okay, so you can use this one. You can calculate the I1 for this one and I2 for this one, and you can add up these two. Or you can add the power first and then you can use 160 watt is equals to, then you can use. Okay, so it's your choice that how you are using. That's all for today. We'll meet you in the next class. We'll discuss this question in the next class. Okay.
Thank you, sir.
Okay, so that's all.